All right, here we go. So in front of you, you have some Hot Wheels tracks, guys. We're recording, and the Hot Wheels tracks are mounted to the center. Well, it's the sink, but they're mounted in this fashion. Okay. And so we're going to do a lab today. The motion sensor is right here. They kind of have, some of them are upside down like this, which is fine. But you know how the motion sensor works, right? It's like radar. It sends a little clicking sound, and then how long, depending on how long it takes for the clicking sound to get back to the device, determines the distance, and then from there it calculates the velocity. Okay. But what we're going to do is we're going to talk about the conservation of energy. So the conservation of energy means that whatever you have in the initial has to be equal to the energy in the final. And then they won't. Well, how come they won't? Non-conservative forces, things like friction. So friction will throw it off a little bit. But we can get a pretty accurate measurement. Okay? So basically what we're going to do is we're going to take our little Hot Wheels car. We're going to set it up here at the top of the hill. Is it moving at the top of the hill? No. So the velocity of the car at the top of the hill is equal to 0 meters per second. All right. And the car, I don't know what I'm thinking. I forgot to finish drawing the car. Okay. Perfectly drawn Hot Wheels. But there's a couple of things that we do know. One is that it is a height above what we're going to consider the tabletop, your guys' desktop, as y not, or no, that's actually y final, right? So it'd just be y equals 0. And actually, I'm going to move that over here. This value is y equals 0 meters. And this would be like y naught, but we'll call it h. Okay? So the final position down here is 0. The initial position is h. Also, this car has a mass. Okay? So the first thing I want you to do is I want you to take your car, set it on the scale, and weigh it. So what was that you had again? 31.73. So they had 31.73 grams. But remember, for all the math to work, we want it to be in kilograms. So you just put 0.0 and then whatever you have. So you said 31.62. So yours would be 0.03162 kilograms. So you're just going to, really what you're going to do is you're just going to put a point and a 0, and then the rest is the number that you see on your scale. We need to convert that to kilograms. Okay? And I know what you're thinking, Mr. Adams, what does this have to do with our lab? So what I want to do is I want to see if the energy is conserved, or how much of it's conserved. So in the initial, there's two parts. I have potential energy, so I have the mass times the acceleration due to gravity, g, plus the kinetic energy, which is 1/2 times the mass times the velocity, v naught, squared. Then my final energy will be the same thing. How much potential energy will I have? Plus 1/2 times the mass of the car times the final velocity squared. Okay? one thing I want to point out, in the initial part, my initial velocity is 0, so that means I would put a 0 in here. 0 times all this stuff is 0. So my initial energy is just the potential energy. Okay? Now for the final, my final position, which is really like H, if I wanted to, I could call this H naught, and I could call this the final position H. So this is H. We'll call this H naught. The final position is 0, so this whole thing ends up equaling 0. 0 times all that stuff is 0. So I'm left with 1/2 times the mass times the velocity squared. Okay. So we're going to do a lab today, and we're going to do it over and over and over. Our goal is to get a minimum of 40 trials. You say, that's a lot of trials, Mr. Adams. Yeah. We're going to do 40 trials because that's acceptable. That's an accepted practice in science. Why 40 trials, Mr. Adams? Well, the statistics work out better. You're going to have some outliers. You're going to have 1 or 2 of these items that just don't match the rest of the data. So the more we record the trials, those 1 or 2 outliers don't have a huge impact on the overall numbers. Okay. You generally, when you're doing real science research, you don't want to toss out the outliers. You just leave them in there. You try to figure it out. Somebody in here is going to push the car down the hill. And when you push the car down the hill, it's going to add extra energy to the system, and they're going to have a really high velocity at the end of this. All right, so let's start plugging in some numbers here. We know that G is the acceleration due to gravity. What's that number? 9.8 meters per second. All right, what else do we need to know to calculate the potential energy? We need to know H naught, right? What's that? How do we figure that out? Anybody know how we figure that out? Or are you guys just writing stuff down? How do we figure out the height of the top of the hill? Or the track? Or the bottom of the track, I should say. You're going to measure it. Get out your meter sticks and measure it. Go. All right, so this group right here, and you guys should pretty much have the same. You guys pretty much should have the same thing. So they said it was 33 in the second mark, which is really 33.2 centimeters. But I don't want it in centimeters. I want it in meters. So it's technically 0.332 meters. So you guys should have pretty close to the same. Is there anybody that had something way different? All right. So now let's start our spreadsheet. So the one person that had their Chromebook open to do the spreadsheet, put some stuff in there. So if I want to calculate the potential energy, so let's do that. Just type in potential energy, but spell it correctly. What's the unit of measure for energy? Does anybody in here know? Unit of measure for energy. I see that you're being shy today. Extra credit, if you could tell me. Oh, now you know. Joules. It's in joules. Now, how do we calculate that? Well, first I need to type in the mass, which is measured in what? Kilograms. Thank you. Then we need to know mgh. We need to know g, the acceleration due to gravity, which is measured in meters per second squared. I'll put that one in. I'll do that one for you guys. It's 9.8. Then we need to know initial height. Did I spell that right? It looks like hate. American English is weird. And that's measured in meters. So my my group up here, when they measured theirs, it was 0.332, and I'm going to make this bigger so the kids in the back can see it. I'll crank that bad boy up like this so the kids in the back can see it. Okay. Well, maybe that's too big. There we go. All right. Now, what was your guys' mass of your car? Well, actually, you know what? I'm gonna go with the one that I had. So they had 3162. So I'm gonna put this number in. So whatever your mass is, type in your own mass. Okay, guys. Was it 6.162 or 6.3? Yours is 6.4. Who had 31.62? Was that you guys? That was you guys. But now it changed. It got heavier all of a sudden. I'm gonna stick with 6.2. All right. All right. Now I gotta multiply those three numbers. How do I do that on the spreadsheet? I'm gonna come here. I'm gonna hit equals. I'm gonna click math. Then I'm gonna hit times. Then I'm gonna hit G. Then I'm gonna hit times, which is Shift 8. That's how you get that little asterisk. And then I'm going to hit this one. So you should have equals B2 times C2 times D2, which is Shift 8 for that little symbol there for the multiplication. I'll leave it up there for a second so everybody could type it. So enter on this. If I hit enter on this, that's the amount of joules you have. That's the amount of potential energy you have. Okay. Now I don't want to look at all those decimals. So remember this? Remember this symbol up here? If I do this, it just reduces down. Makes it a little lower. I can't go more than what I have, so probably 2 significant digits or something like that. Okay, is everybody on this page? Now the last thing we need to do, we're going to go back to our notes. I want to figure out what the final velocity will be because the car is going to come down here like this. And I want to know what the final velocity is. All right, so I'm going to take this equation right here. I'm going to divide this by m, divide this by m. The m's cancel. And I get GH. So I'm solving for v, right? Is equal to 1/2 times v squared. So I'm just doing algebra to kind of get v by itself. The next thing I'm going to do is I'm going to take this whole thing and multiply it by 2. Whatever I do on one side of the equation, I have to do to the other. This gives me 2 times g times h is equal to the velocity squared. What do I do next to get v by itself? Anybody got a clue? Take the square root of both sides. So I'm going to take the square root of this side. Now this is the square root of TGH. Is equal to v. Okay? So I can calculate the final velocity just by knowing the acceleration due to gravity and the height of the initial drop. Let's plug this in our spreadsheet, shall we? So go back to your spreadsheet. Does everybody have that written down? I don't want to get too far ahead of everybody. All right, so now what we want to do is we want our spreadsheet to tell us how to calculate that. So over here, I'm going to say final velocity. What in the heck? I got to fix that. So you're going to hit equals. Then to do the square root, you say SQRT, start parentheses. We're going to say 2, shift 8 for the multiplication symbol. We're going to multiply that by G, so I select G. Then I hit shift 8 again to get the multiplication symbol. Then I select the height. So SQRT, open parentheses, 2 times S2 times D2. Does everybody have that? All right, I'm going to hit enter. So it's about 2.55. So I'm going to reduce the number of decimals by doing this. So about 2.55. What's the unit of measure for velocity? Meters per second. What the heck, man? All right. Any questions so far? So you should have similar numbers. If your mass is different, it still should be close to about 2.55. Okay? You guys are going to need to take two parts of your track off this first one because your track's too long. You're going to have really low numbers. All right, so now the next thing we're going to do is we're going to say trial over here. And we're going to go 1, 2, 3. Remember how we repeat the pattern on that? Select all 3 of these. Yeah. And try to line that up. Make sure it's lined up. Right now it's kind of on the cord. You got to move that cord a little bit. There you go. All right, now if I wanted to do a bunch of trials, what I want to do is I want to highlight 1, 2, 3, grab the blue dot, and then just go way down here. Like that. And then what we're gonna do is we're gonna put down just put EMP for empirical, and then velocity. Okay. So what you're gonna do is turn on your LabQuest real quick. So what you're looking for in their data, I'll write this down real quick so you guys can see it. In the data on the LabQuest, it'll say time, and then it'll say position. What's the next thing it says? Does it say velocity? On the data, what's tell me what that the headings. Time, position, velocity, and acceleration. No, but just tell me the headings. Time, position. No, listen to me. Tell me the words above the numbers. Okay. Okay. So you're going to look for them. They had a bunch of different velocities. The 1.316 velocity, which is in meters per second, they had the shortest position, which was 0.446. That means it picked it up about 44 centimeters from the motion detector, which, if you were to measure that out, it's almost at the bottom of the hill. Does that make sense? So as soon as that car came into the path of the motion detector, it picked up its velocity. Now they had other ones. There was one above that was like 2.5 meters per second roughly, but that had a position of 0.666. 0.69 or something like that. That's not the one we want. That's not the one we want. The one that we want is this one because it has the shortest position. So that's how you're going to identify the velocity. Okay? And you have to scroll through it because it does bounce off of the motion sensor, and it does some wacky things just like the t-shirt drop, right? When the t-shirt actually hit or got close to the detector, it did some wonky things. So that's what we're going to look for, and then that's how we know what to plug into our spreadsheet, okay? So then over here, I'm going to plug in 1.316, and then I'm going to do, and also write this down in your notebook. In the screen, it'll have the word file and table. So before you do your next thing, when you select table, one of the options underneath table, way down at the, it's about 2/3 of the way down, it says clear all data. That's how you clear the data out of the table, okay? And I'm going to come around and help you get started. But we are doing this for the rest of the class until I say stop. So some of you will get 30 trials. Some of you will get 60 trials. You just keep doing it and recording the data. Does anybody have any questions? Okay, that's it. Let's get started.